So how many squares and rectangles are in this picture? If your answer was 4 or 5, well, you're wrong. You probably counted the 4 single squares in this picture, and some of you might have noticed the big square on the outside, but don't forget about the rectangles. There are 2 vertical rectangles, and there are 2 horizontal rectangles, so in total, that makes for 9 squares and rectangles in this picture. Here's another problem. How many triangles are in this picture? This one is more tricky. In fact, whereas in the previous question we could just count the number of rectangles and squares, this time let's try and use different cases. In other words, different categories that we can count. So there's the category of the smallest triangle that's just made of 1 triangle. There's the category of the next smallest triangle, which is made of 4 triangles. And then the next one is made of 8 triangles. And the final one is made of 16 triangles. So those will be our cases, and we'll just count the number of triangles in every case and add them up to find the total number of triangles. Let's count how many single triangles there are. There are 16 single triangles. Now, let's count the number of the next triangle. There's 1 triangle up here, there's 2 triangles in the middle row, and there are 3 triangles in the bottom row. So you would think that there are 6 of these triangles, but there's actually 1 triangle that is upside down in the middle. So that actually makes for a total of 7 triangles. Now let's count the number of these blue triangles. This one is a little easier. There are only 3 of these, 1 at the top and 2 at the bottom. Finally, the biggest triangle, there's only 1 of them. So now if we add up each of these cases, we'll find that makes for a total of 27 triangles. And that is the answer. Using casework can make problems like this a lot easier to solve. Let's do another triangle problem. How many triangles are in this star-shaped figure? So again, this can be a little confusing. So let's write out our different cases, all the different possible triangles that we can find in this picture. So first, we have the single triangles. Then we have the triangles that are made of 4 triangles. And then finally, we have our biggest one, which is made up of 8 little triangles. Single triangles, we can count them by hand, and there are 12 of them. For the next triangle, it may be a little tricky to find them at first. There's actually 1 of these triangles at every point of this star shape if we outline it here. So there will be 6 of these because there are 6 points on this shape. Finally, for our biggest triangle, this one is actually a little bit hard to spot. The 3 corners of this triangle are made up of corners of the star. So there will be 2 of these that you can find in this picture. And if we add this up, there will be 20 of these triangles to find. Now let's do a slightly different problem. So we have this grid of evenly spaced points. All these points are 1 unit apart. And so the question is, how many squares can you make by connecting 4 of these points together? Again, this is easier done by dividing the problem into the different cases. So what are the different types of squares you can make from this grid? So first, there's obviously the single square. That's easy. And we can count them. There will be 9 of them. And next, we have the squares with side length 2, which we're doing in green. So these, again, we can just count by hand. And there will be 4 of these. Finally, we have our biggest square, the square with side length 3. And there's just 1 of that one. So this seems pretty easy. So we can add up the total and we get a total of 14 squares. But there's something we forgot. There are actually more than 14 because since this is a grid, you can connect the dots any way you want. The square's side lengths don't have to be vertical or horizontal. They can be diagonal. And so you can actually make a diamond looking square, but that's still a square because all the side lengths are the same length and the angles are all 90 degrees. So that is actually another square we can make. So we have to count that one too. So if we count the number of these, there will be 4 of them. Is that all? If we check through every possible side length of square, we'll find that there's actually another one we missed. This square is weird. It's like a diagonal square. It's not even like a diamond. It's just a diagonal square. So there's actually 2 of these as well. And again, it's a square because all the side lengths are the same length and the angle is 90 degrees. And so there are 2 of these that we have to take into account. There are no other side lengths that work because the other ones will be too long or they're so short we already counted them. Those are all the cases. So now we can add them up to find the total number. And that gives us a total of 20 squares. So what is casework? Casework is just when you split a bigger problem into smaller tasks, which makes it a lot easier to solve. So in our examples, we used like counting different shapes. So instead of just randomly counting squares, you can count all of a certain type of square and then figure out all the different types of squares you need to remember. And another thing about casework is that it does help you think outside the box. Sometimes if you realize that all of your cases are very similar, there might be something else that you forgot, just as in our grid problem, all of our squares were very boxy, typical looking squares, and we forgot about all the slanted and tilted squares that we still needed to count as well. And so overall, casework, it just makes your life easier. It's great.